All right, guys, so continuing with the concept of U-substitutions, we're going to also have some trig functions like we did on the warm-ups. In the warm-ups, though, our angle was just x, so we didn't need to use a U-substitution on the angle. However, if we have a trig integral and the angle is not just an x, we're going to need to do a U-substitution on that, okay? But there are some times where the angle is not an x, but we also have a product. If we have a product and we have an angle that's not just an x, we're going to have to let u equal another part of the problem. But looking back at this one, this is just a cosine. It is not a product. So therefore, on this one, we're going to be letting u equal 8x. But let's start with the first one, and let's look at a special case here. So we can see that this is a product if I cannot multiply it out. So if I can't multiply it out, I have to do a u sub. So I'm thinking of the problem like this. U has to equal x minus 1. But when I go to rewrite this problem, right here is my u. I also have du would just be dx. Here's the u. I'm plugging in u for that to the 1/3. For dx, I'm just plugging in du. What is the problem, though? What's the issue here? I replaced this, I replaced this, but what have I not replaced? The x. This would still have an x in it. Never in calculus will we have different variables in the same problem. So to get around that, I have to solve this for x and replace it into the integral. So if we replace this for x, what are we going to have? X would be what? U plus 1, right? So now, in this x position right here, I would have to put in u plus 1. And that should solve our problems. We should now be able to fix this up so we can integrate. Here's how we do it. I can now distribute. So u to the first times u to the 1/3. Jared, what would that be? U. Right, so it's going to be u to the 4/3 plus, and now I distribute this. Riley, what's that going to be if I just have u times u to the, or 1 times u to the 1/3? Right? So we have this now. So we have to integrate. Our method for integrating is that we have to add 1 and we have to multiply by the reciprocal. So there's what we would get on the first term. On the second term, I would have to add 1 and multiply by the reciprocal. To finish the problem, I just have to go back and look at what u is, and I have to fill it in. So we're going to have 3/7. Here's u plus 3/4 u plus c. That's going to be our answer. Any questions with that? All right, on number 2, we're looking at what we've got here, and we have to realize that this angle, like I said, is not just an x. So if the angle is not an x, we're going to have to let u equal 8x. If we take the derivative of that, we get 8 dx. Guys, look at the problem here, though. Now when I go to fill this in, I'm going to have the integral of cosine u du. Well, I don't even have the du yet. Actually, let me get rid of that because it's not there yet. See, all we have so far is just the fact that u is 8x. So I have to replace a 4 dx. How am I going to make this a 4 dx? Not multiply by 2. Divide by 2 or multiply by 1/2. So I multiply by 1/2 here and I multiply by 1/2 here. So that means 1/2 du is going to be 4 dx. And that's what we needed to replace, 4 dx. And that gets replaced with 1/2 du. All right? And now it's just a matter of integrating. Sean, do you know the integral of cosine? Sine. So the integral of cosine is sine, so I'm going to have 1/2 sine u plus c. I look back to see what u is. U is 8x. And there's our final answer. Guys, this is something that I would always use anytime I was taking a calculus quiz that involved derivatives of sine and cosine. I would write this out. We start with sine. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. What would be the derivative of negative sine? And then what would be the derivative of negative cosine? Sine. I would always write this out, and then I would know if I'm going down this way, these are all derivatives. If I go back up, these are all integrals. So if I quickly need to know what's the integral of cosine, I can see that that's going to be sine x. I always like doing that. I would put that on my green sheet if I were you, because if you're in a hurry, it really does save time. Because it's easy to get confused, like, what's the integral of sine? Is it negative cosine or positive cosine? All right, now looking at the difference between these two. This one, I did not have a product, so I let u equal 8x. This one, however, I have a product, so I cannot let u equal just 3x. I have to think of this problem as the integral of sine of 3x squared cosine of 3x dx. So now we have to think about what we should let u be. Good. Riley's right. We're going to let u equal sine of 3x. Because now when I take this derivative, the derivative of sine is cosine. So I'm going to have cosine of 3x, but I have to use the chain rule. The derivative of sine 3x is not just cosine of 3x. What is it? I have to use the chain rule, so it's times 3. So I have to put a 3 in front, dx. That will be the common mistake on the quiz, on a problem like this. People will take this derivative and just call it cosine 3x and not 3 cosine of 3x. All right, so now let's look at what we're trying to replace. We are trying to replace this. We can already replace that with u. This right here is just our u. But we have to replace this. What do we have extra here that is not needed? 3. How do I get rid of it? 1/3. So I'm going to multiply this side by 1/3, this side by 1/3. Now those cancel. So my cosine of 3x dx that I have in this box, here's my u. It's getting squared. The box is just going to be 1/3 du. I like to put the constant out in front. Some people keep it inside. That's totally fine. I just keep it in front so it's kind of out of the way. So now to integrate, I carry down my 1/3. I just add 1 to this, and I have to divide by that. So that's going to give us u to the 3rd over 9 plus c. And then we just have to go back and say, okay, what was u? Well, it was sine of 3x. So it's going to be sine cubed of 3x over 9 plus c. What questions do you have? All right. Let's go down to number 4. Use integration to find the particular solution of the differential equation dy dx equals if y passes through 0, 1. Brittany, do you remember what it means when it says dy dx? Right. The derivative of a function with respect to x is this. So if this is the derivative and we're trying to find the original function, what do we do to the derivative? Integrate it. So this is the derivative, so y will be equal to the integral of this. A very important thing to understand before you go off to college level math is that when the squared is here, it means the whole thing is getting squared. When the squared is in this spot, it's only the angle that's getting squared. It's not the whole sine. So this one really means that. Do you see the difference? It's the sine of, first thing that would happen would be that the angle gets squared, and then you would do the sine. All right, so we have a product. That means we have to use a rule that will get rid of it, meaning a u substitution. What do we let u equal? X squared is right, Chase. So what if we take the derivative then? 2x dx. We look at our problem. Here's our u. That's good. We will have sine u, but we want to get rid of x dx. What do we have to do? Multiply by 1/2. 1/2 here, 1/2 here. So then now we're going to have the integral of, here's x dx. That gets replaced with 1/2 du. U was just x squared, so I'm going to have this. That's what we have to integrate. So now to find the integral of sine u, well, I'm going to go here to my list. Go to sine x, go up to find the integral, and it's negative cosine x. So this integral is going to be negative 1/2 sine x squared plus c. That's what y is equal to. Questions on that? What? Oh gosh, I'm sorry. I said cosine and I wrote, let me fix that. Sorry about that. It's y equals negative 1/2 cosine of u plus c. There we go. Which is y equals negative 1/2 cosine of x squared plus c. So there's our integral. All right, now that we have our integral though, if we have to find the particular solution, that's asking us to figure out what c is. How are we going to figure out what c is? Plug in the points, great. So we're going to plug in 1 for y, and we're going to plug in 0 for x. 0 squared is just 0. Now we have to evaluate this. Do you know the cosine of 0? Think of your unit circle. Here's 0. What's the x value there? 1. So cosine of 0 is 1. So 1 equals negative 1/2 times 1 plus c. So c then is going to be 1.5. Well, that means that we can go ahead and rewrite the equation. Y equals negative 1/2 cosine x squared plus 3/2. That's going to be the function that has that derivative and that goes through that point. Now, I can check this. Watch what I can do. Negative 1/2 cosine of x squared, maybe, okay, I'm going to check my mode. I prefer to be in radians on the mode. Doesn't really matter, but then I want to do a zoom trig, and I'm going to look at the function. All right. This is the way that the function looks. I want to make sure that my function passes through that point 0, 1. So I'm going to look at my table. Oh, I forgot the plus 3/2. Thank you. All right, so there we go, 0, 1. Okay, makes sense? We can check. All right, let's go down to the last part here. I want you to take a couple minutes. I want to know, is a U-substitution helpful? Sometimes it is, sometimes it is not. You need to be able to distinguish when it's going to work, when it will not work. Take a couple minutes, yes or no. Should you do a U-sub? Taylor, what'd you say on the first one, yes or no? No is correct. Because we can just divide each one of these and get rid of the x squared.
True.
What about letter B?
Yes.
Yes? Do we agree with yes? Yeah, because if I let u equal this, see look, if I do u equals this, that derivative is exactly the same as the numerator. So yes, that's going to be helpful. What about here? Is it helpful or not?
Yes.
Yes, because if I let this be u, the derivative's that, so yes. And what about this one?
Yes.
That's a negative. This is not. The reason why is because this can be done without a u substitution. What could we do here? Just distribute it out. Okay? All right, guys, you just want to power through the notes so we don't have to come back to them. Let's flip over to the back.
Too much information.
Oh, you can do it.
I'm setting myself up for
All right. There are two types of integration, guys. Two types. Definite and indefinite.
One is definite.
Correct. Yes. Definite is the type when we have numbers here. See, definite is the type when the integrand has these numbers on it. Indefinite is when we have the integral, but there are no numbers on it. Well, I just told you the difference. One has the numbers, one does not have the numbers. See right there. All right, and then we're going to talk down here. Let's go down here first. So what does integration find? Well, one thing it can do is just find the original function, f of x. We can find c if necessary. If we have a definite integral, you want to put definite integral here. This will be indefinite. So definite integrals find the area under the curve, meaning whatever the function is, bounded by the function, the x-axis, and the x values that are given. The other thing that integration can find is the average value, meaning the average y value. Remember that average value? It was 1 over b minus a times the integral from a to b of f of x dx. Did that before spring break, a little while ago. So those are the three things we can do. Now, here's the important thing too. What methods do we use to integrate? If you can just integrate, do it. All right? We've learned this fancy U substitution, but that doesn't mean we have to use it. right? A lot of people have fancy cars, but they don't drive them every day. They only drive them on special occasions. If we have a problem that does not require a fancy method, we're not going to use the fancy method. We're just going to be simple and use the simple method. Simplify to get terms. If the function can be multiplied or divided out easily, don't do a U-substitution, okay? Only do a U-substitution when it's necessary. This is the biggest problem people will have on our next quiz, is they'll want to use a U-substitution on every single problem when it's not necessary and it's not helpful. So don't try to be fancy and use U-subs when you don't need it. All right, so this is one thing we have not done, is a definite integral with a U-substitution. All right, take a look. Brandon, what are we going to let U equal?
X squared plus 1.
You got it? U is x squared plus 1. That derivative is going to be 2x dx. We want to replace the x dx. So what's the x dx? What am I going to have to do to get the x dx? Multiply by 1/2. So x dx is 1/2 du. So I rewrite the problem. I've got the integral of x dx is 1/2 du. Here's my u. It's getting cubed. This is actually easier than what we were doing a minute ago. Definite integration, these are x's. I'm going to change them into u's. Look, this is saying x equals 0, x equals 1. Now I'm going to make them u equals what? Well, if x is 0, I plug it in here to find out what it would be as u. 0 squared plus 1 is 1. 1 squared plus 1 is 2. I will never have to go back to x's now. In fact, I could just get rid of all of this and never look at it again. This is my new problem to work. So let's integrate it. What's the integral, Sean? What's the integral of this? Not 1/3, but 1/4. So it'd be 1/4 u to the 4th. And all I have to do is substitute in 2 and 1. I'm going to simplify. I've got 1/8. And I'm going to put my u to the 4th on the top. See what I'm doing there? I just did 1 times 1 times u to the 4th, 2 times 4. So we plug in the top number. So we have 2 to the 4th over 8 minus 1 to the 4th over 8. 2 to the 4th is 2 times 2 times 2 times 2. That's 16. Divided by 8, that's 2. 1 times 1, that's 1. Divided by 8, that's 1/8. 2 minus 1/8 is 1 7/8. That's my answer. Guys, definite integrals can always be checked. And it was obvious from the last quiz that a lot of you did not check the definite integrals. Look, here's what I do, guys. I put in my original function. Here's my original function. I'm going to graph it. I do a zoom 6. The calculator can find the answer to this area under the curve. I go to second trace. I go down to integrate, which is number 7. My lower limit is 0. My upper limit is 1. Here's my answer, 1.875. That is...
It's 0.875.
7/8 is 0.875. If you're not sure about that,
Just
right? Same thing. All right. So we should always check those. In fact, I would rather you get the right answer on a definite integral by using your calculator than sit there and struggle through it and just get it wrong. Be smart. Okay. I might take off a couple points if you're not using calculus at all on any definite integrals, but still check it, okay? Number two, guys, this one's a little tougher. What's our u going to be?
X plus 2.
Good. What's du? 1 dx. All right, so let's look at what's going on here. So here's my x plus 2. That's u. What's happening to it? It's getting raised to the 1/2. I have an x dx and that I have to get rid of because I already got rid of this. But I can't get rid of it right now, so what do we do? How do I get rid of the x? What do I do right here? Right. What's x equal? X would be not just -2. U minus 2. All right. So watch, guys. My 1 dx gets replaced with du. That was fine, my 1 dx. But this x has to get replaced with u minus 2. So I got to squeeze that in here. Now, these numbers here, they were x's. I want them to be u's. So I have to plug in -1, -1 plus 2 is 1. Plug in 2, 2 plus 2 is 4. So here's my new problem, the integral from 1 to 4. And now I can distribute this out. U times u to the 1/2. It is. Minus 2u to the 1/2. Now we would be ready to integrate. So we have to add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal from 4 to 1. What do we do now with this? Plug in the 4. So I have to plug in 4. This is my root, and this is my power. So what is the square root of 4? 2. What's 2 to the 5th? 32 times 2. Woo, nice math. 64 fifths.
Wow.
Okay, now we have to plug in 4 here. What's the square root of 4? To the 3rd times 4. So we have minus 32 thirds minus, what's this going to be if I plug in 1? Just going to stay the same, right? Well, I'm saying overall, 2 fifths minus 4 thirds. Okay, at this point, I would go ahead and get out the calculator. It's a lot of math for 9 in the morning. All right, shh, watch. Here's our answer. I'm going to math frac that. We get 46 over 15. Now, I go through all this work. What should I do?
Check it.
Check it. Yes. So let's go back to y equals. Just do a real quick check. X square root x plus 2 zoom 6. What's the answer to that integral? Number 7 from -1 to 2. And it is 3.06667. We know that we're great mathematicians and that we are correct. All right. Feel good about that? You should.